Myself Shweta Shah. We are here for the subject Computer Organization and Architecture. In this subject, we have started with Unit 1, that is Computer Data Representation and Register Transfer and Microoperation. In this unit, we are going to see today the topic that is Common Bus System for 4 register using MUX. Before starting with topic, let me see what is bus and memory transfer. A typical digital computer has a many registers and paths must be provided to transfer the information from one register to another register, and the number of wires will be excessive if the separate lines are used between each register and each register to all other registers in the system. For example, let me consider one example in that we have total 3 registers and each register is having 4 bits like register A, B, C, and each are having 0, 1, 2, 3, 4 bits. Okay, so to connect this register A and B, B and C, and A and C, you require to connect each and every bits of this register. Okay, so 4 lines are required to connect register A and B, 4 lines are required to connect B and C, and 4 lines are required to connect register A and C. Okay, and in this line the two-way communication can be done. So register A can transfer to C and C can transfer to A on the same line. Okay, so here we will require total 12 lines to connect these 3 registers, each are having only 4 bits. Okay, but what if your system is having 32 register or 64 register and each are having 8 bit or 16 bit or 32 bits? Okay, so if we consider if your system is having 32 resistors and each are having 32 bits, so you will require 32 cross 32 connection to connect all of this resistors. Okay, so this is too large number and that is not possible to design. Okay, so instead of that we can use this common bus to connect all of these resistors. Okay, and this is a efficient scheme for transferring information between one resistor to another resistor. Okay, this is known as a bus structure, and this bus structure is consist of set of common lines, one for each bit of resistor through which binary information can be transferred one at a time. Okay, and the control signal will determine the which resistor is selected by the bus during each particular resistor transfer. So if you are going to use the common path for each and every resistor, so at a time you can have only content of one resistor. Okay, you can't transfer all of resistors contained on bus at the same time. So you must require to have some control so that at a time only one resistor's content is available on bus, and that is done by this control signals. Okay, and there are many ways to design this common bus system, like you can use multiplexer, you can use decoder, anything, but the most common or simple way you can use multiplexer. So let me see how you can use this multiplexer to design your common bus system. Okay, we will see one example of common bus system for 4 resistors using MUX. Okay, you can design like this. We are going to using 4 resistor and each resistor is having 4 bit. Okay, here we have used resistor A, B, C and D, and each are having 4 bit, and this bits are represented. For A it is A0, A1, A2, A3. For B it is B0, B1, B2, B3 and so on. And here we have used multiplexer, 4 multiplexer. You all are aware of multiplexer circuit. Multiplexer circuit is having 4. If your multiplexer is 4 cross 1, then it will have 4 input, 2 selection line and 1 output. According to your selection, any of your 4 input is selected and provided into output. If your selection is like 1, 0, its decimal equivalent will be 2. That means your 2 number input that you have given at pin 2 is going to be provided into output. Okay, so your input is selected according to your control and given into output. Okay, so how we can use this concept in this multiplexer, let me see. For our 4 resistor, each same position bits like 0th position, 1st position, 2nd position, 3rd positions are provided to a single multiplexer. Like for a third number bit, for D resistor it will be D3, for C resistor it will be C3, for B resistor it will be B3, and for A resistor it will be A3, that are provided to this mux 3. Similarly, D2, C2, B2, A2 are provided to this mux 2. D1, C1, B1, A1 are provided to mux 1, and D0, C0, B0 and A0 are provided to this mux 0 as an input. Okay, here only connection for this 4 bits are shown. Otherwise, you have all of this connection done. But for simplicity, we have shown over here only 4 connections. Okay, and rest of the bits are represented by its number. So here we are providing same position bits to same mux. Okay, and here next we will provide this selection. Okay, so according to this selection, your any of this input is going to be selected and provided into output. For example, if you want to transfer the content of resistor B to the bus, so you have to select B3 over here, B2 over this mux, B1 over this mux, and B0 over this mux. Okay, so for this selection you have to select input number 1 of mux into output. Okay, because one is connected to B0, here one is connected to B1, here one is connected to B2, and here one is connected to B3. Okay, so we require to provide here B3, B2, B1 and B0. So for that you have to select over here one number input, and for that selection you will require selection as a 0, 1. You have to provide selection 1. Okay, so according to that selection, any of this mux's input is going to be selected and that is going to be provided into output. Okay, so here you get the output as a B3, B2, B1 and B0. Similarly, if you want to provide the content of C resistor to the bus, then you have to select this second input. Okay, this second input is connected over here is to C2, sorry, at C3, here at C2, here at C1 and here at C0. So you require to select this second input of this mux. And to select that second, you have to provide here control as a 2, that is 1 0. So here S1 will be 1, S0 will be 0. So your C resistor is provided to the bus. Okay, and so on. For A resistor you have to use selection 0 0, and for D resistor you have to use selection 1 1. Okay, so by this way you can design a common bus system for 4 resistor. Here we have used 4 resistor, each consisting of 4 bit, and to design this system we require 4 cross 1 mux. Okay, so as we have already discussed this all things that we have connected over here, and here we are using selection line S1 and S0 to select inputs of all 4 mux, and the selection line choose 4 bits of one resistor and transfer them into single common bus. Okay, here we are using same selection for all of this resistor, so same resistors content is going to be provided into bus. Okay, if it is 0 0, then 0 data input of all multiplexers are selected, and that is resistor A. If it is 0 1, then resistor B, then 1 0, then C, and 1 1, then D. Okay, and then this will transfer this content to the bus. Okay, so here I have given the table for this. For resistor A we have 0 0, for B we have 0 1, for C we have 1 0, and for D we have selection as of 1 1. Okay, for example, if we want to transfer the content of resistor C into resistor R1, we will write this statement like this: transfer the content of C to A. But for this actual transfer, First, the content of register C is going to be transferred to the bus, and then the content of bus is going to be transferred into R1. So first you have to select register C for transferring its content into bus, and then you have to select register R1 to transfer the content of bus into register R1. Okay, you will write the statement like this: transfer C to A, but actual operation will be C will be transferred to bus, and then bus will be transferred to register R1. Okay, this will be actual operation. So for if we want to generalize this criteria, we have seen this for only 4 resistor. But what if you have many number of resistor, another number of resistor? Okay, so for this generalized criteria that we are going to define how many multiplexer you will require, and what will be the size of the multiplexer that you require to design your common bus system. For general case, let me consider that we have total k resistor. Okay, and each resistor is having n bit to produce the n common bus, n line common bus. Okay, so that is clear that our bus will be of n bit. Okay, because our resistor is of n bit, and there is total k resistor. So one thing, the total number of multiplexers that are needed to construct the bus is equal to n. What is n? That is number of bits in each resistor. Okay, so if your system is having 32-bit resistor or 16-bit resistor, so you will require 16 multiplexer or 32 multiplexer depending upon your size of the resistor. Second thing, you will the size of each multiplexer will be k cross 1. What is k? K is the number of resistors. Okay, for example, if we consider that if your system is having 8 resistors and each resistor is consist of 16 bit. Okay, so you will require n multiplexer. How many bits are there in each resistor? That is 16. So you will require 16 multiplexer, and each multiplexer will be of size 8 cross 1. Why? You have to select from 8. Okay, that is, you have 8 resistor, that means you have to select from 8 resistor. So your selection will be of 8. Okay, so for this selection you will require 8 cross 1 marks, and it will have 3 selection line. Okay, similarly you can find out for any number system. For example, if you have a 16 resistor and each resistor are of 32 bit, that means you will require 32 multiplexer and each having size of 16 cross 1. Okay, so by this way you can generalize your criteria. So we are ending our today's session over here. If you have any query, then you can contact me or write in a comment box. I will try to solve your query as soon as possible.